This is part 3 of the arc and angle relationships lesson. On the third page of that notes packet, you have special inscribed angles. An inscribed angle, as you recall, is where the vertex sits on the circle. And there's some special cases where it's not just a chord that is creating the angle. In this case, you can see you've got a radius and a tangent line that have a intersection that is on the circle. This is still considered an inscribed angle, whereas half of the angle is half of the intercepted arc. Now, in this case, I could extend that radius to make it a diameter, and that intercepted arc would be 180 degrees. Now, a tangent line to a circle, that tangent line is always going to be perpendicular to the radius drawn from the center to the point of tangency. So, anytime you have a tangent line and you were to draw from the point of tangency straight to the center, it will always create a perpendicular angle. Now notice that, like I said, when I extended that radius and made a diameter, you can see that the intercepted arc is a semicircle, 180 degrees. And so the inscribed angle there is 90 degrees. And DF is your tangent line here. And it is tangent at point D. So we have line segment AD is perpendicular to that line FD. So anytime you have a radius or a diameter that touches the tangent line, it's always going to create a 90-degree angle. Always will be perpendicular. Well then, in this case, you can see that you still have the vertex sitting on the circle, but you have a chord and it's touching a tangent line. Now this time, it's not going through the center, so it's not perpendicular. However, you still have an intercepted arc here. So, put that chord in the wrong place there. It is still half of the intercepted arc there. Alright, so you have your intercepted arc, and I'm going to highlight it in yellow here. So that's arc AB. And then this angle, ABC, is going to be half of that intercepted arc. So AB is a chord for the circle, and BC is tangent to the circle at point B. So we have angle ABC is formed by a tangent and a chord. If the measure of angle ABC was equal to 85 degrees, so if you had 85 degrees for the measure of that angle, and you wanted to find the measure of the arc, well, to get the measure of the arc by itself, you could multiply both of those by 2. So if you multiply times 2 right here and 2 right here, 2 times 1/2, that makes that 1. So then you just do 2 times 85. So basically you're going to double the degrees of the angle to get the measure of that intercepted arc. And that would give us 170 degrees for the measure of the intercepted arc. Okay, so let's say if the measure of the arc is 140 degrees, what is the measure of angle ABC? Well, the measure of the angle is going to be half. So we have to take, since the arc is larger than that inscribed angle, so we would half it, and we would make that 70, because half of 140 is 70. Now for the last one, it gets a little trickier. It says if the measure of angle of arc ADB, they are referring to start at A, go over to B by first going through D. This large arc there is 200 degrees. This large major arc, it's greater than 180, is 200 degrees. So if this is 200 degrees, then the measure of this minor arc is going to be 360, which is the entire circle, minus the 200, and that gives you 160 degrees for the measure of this intercepted arc. So if this intercepted arc is 160, remember your inscribed angle has to be half of that, so now we get 80 for our inscribed angle there. And another case is where the inscribed angle always forms a 90-degree inside the circle. Notice in this case it is intercepting what we call a semicircle. RSQ is a semicircle. And the inscribed angle there is always going to be 90 degrees when it intercepts a semicircle. Well, that's because the semicircle is actually equal to 180 degrees. And if you take half of 180 degrees, you get 90. So anytime you see an inscribed angle that includes the diameter as and the semicircle, it will be 90 degrees. So for circle O, you have angle RPQ intercepts semicircle RSQ as shown. And that concludes the special inscribed angles part 3 of this lesson.